One type of middleware that I do want to talk about is this notion of enterprise application integration. This is a special type of software that basically uses what's called a message broker. And what it does is it has a level of functionality that's different than other systems. It does what's called guaranteed delivery, which means if one system sends a request, that message is going to get to the other system no matter what. It will store a copy and guarantee the delivery of that message. And so that guaranteed message is actually extremely important. In databases, we have things known as two-phase commits, which basically guarantee that the record you're trying to put into the database is definitely making it to the database. Now you may ask, well, when does that when does it not get into the database? Well, if you're in the middle of writing a record and the system fails, well, that record's not in. But does your application know whether it made it in or not? It needs a confirmation back to understand whether or not that record made it in. In the case of this, the message goes into the queue and it stores a copy, and it basically gets another response. This is an acknowledgement, what we call an ACK, or a NACK for a not acknowledgement, that says, no, I did not receive this, or yes, I did receive it. And once it knows it received it, it can send the message back to the calling application saying, yes, your message made it through. I have made sure that it did. Some of the products that do this are TIBCO, JMS, WebSphere, BizTalk is another example. When we're designing these types of applications, this is a message-oriented architecture. Basically, each one of the applications here represented by the clear circles basically puts information onto this message bus. Applications can send and receive messages at the appropriate time in what's called an asynchronous manner, which means I put it in and I don't have to wait for a response. The response will come when it needs to. And this is important because if you're doing synchronous transactions where you have to wait for a response, you could slow your system down. By doing it asynchronously, you can handle many more transactions and allow the middleware to basically feed them to another system, get the responses back, so that you can handle more of these requests at a time. You're not being held, so you're not holding the resources waiting for a response back. The message layer controls the distribution of the transactions. Which system is it going to? And did it get there? And what was the response? So it knows how to handle all of that. The internet systems are basically, the reason they're so good is because they're scalable, they're reliable, and it's easier to integrate with them because they use a standard technology. Everybody kind of knows how the internet works. We use the same kind of general language. Some of the technologies are the same. They integrate pretty well with each other. So developing these web-based and internet-based systems are actually pretty good. So companies recognize that they have to negotiate the language differences. So for example, you have old COBOL applications that need to get ported to Java, and there are a lot of tools out there that will allow us to basically create wrappers. What you don't see them necessarily rewrite the COBOL application into Java. What they'll actually do is they'll write a layer that it wraps around, say, COBOL functionality in Java, so that another system that's trying to communicate to it in Java can make a direct Java call. And then on the receiving end, that Java piece knows how to communicate with the COBOL piece. So you're separating away that integration layer by putting it onto the application by creating this wrapper layer. So you see that technique used a lot. Application servers are basically originally conceived as a piece of middleware. Basically, they're linked between the web server and other systems. So on your slide here, you'll see that we have a web server. Here's the web browser client. This might be you. You make a request for a web page, and then it goes to this application server. The application server is what does the work. What we try and do is we try and separate the presentation of the web page, which is just, say, HTML, and the actual work done. So when the request comes into the web server goes to the application server and says, what work do you want to do? The application server then may integrate with a database, an ERP system, legacy system, pull all the data and say, here, to the web server, go now display it to the client, because it's a lot faster to do that. So you can create 3 or 4 of these smaller web server clients, these web servers that will just keep throwing data and the information out, thereby minimizing the load on your application server. We see this specifically in what's called a 3-tier architecture. The 3-tier architecture is what you see kind of here, where you have the web server as 1, application server is sitting in the middle as 2, and then the persistence layer here, which is basically where the data is stored or where the application is stored. So we have the presentation layer as 1, we have this business logic layer, which is 2, and then the persistence layer where the data is as the 3rd. So this is a 3-tier architecture. The types of development platforms that we use. Now, again, there are many, many languages that can be out there or that are out there that can be used. Your company may have a certain skill set, and they will use whatever they're more comfortable with. But some of the ones that are popular are Java, your .NET, which is Microsoft-based. Now, these are two big ones. PHP is also another big one. It's used in many systems. And you'll see other ones like Python, Ruby, Ruby on Rails, Groovy, Grails, many others that are out there. Perl is another one. You'll hear all these different things. You know, they're all different programming languages. They all do generally the same thing. They interoperate with the computer. They'll get data. They'll push data out and so forth. It's just, as some people ask, well, which is better? And my answer is always, they all generally will do the same. Some are a little bit better based on the platform and based on what you're doing. But you have to balance the cost of doing that, the skill set that's required, versus the speed of development. And can I get other people to do this work that might be cheaper? You know, hiring Java people's definitely a lot more expensive than hiring PHP people, and Java's more expensive than .NET. Does that mean you should not use Java? No, it depends on the situation. Java has some great functionality. A lot of the larger applications will use Java, so they're easy to integrate with. And the benefit with Java is it runs on any platform. So that you cannot say the same thing about the Microsoft architecture, which only runs on Windows boxes. PHP, however, is generally, you can run it on any platform. You can run it on Windows, you can run it on Linux boxes. The reason for that is this is a scripting language, so it's a little bit different.